First question is in front of you. Solve this system of linear. Solve this system of linear equation. Look, it seems not too much difficult. You can solve it after understanding concepts behind it. Here, question is saying solve this system of linear equations graphically. You have to plot all coordinates that you will have after solving this. Okay. Uh, Here you can see linear equation. What is what? Linear equation. When word linear equation is coming, then you can be clear that yes, solution of linear equation would be how much? Unlimited, you can say. Unlimited. Infinity. Solution of linear equation would be infinity. It is a fact. It is a fact. We cannot deny it. So if word is a linear equation, it means this linear equation, this and this linear equation will give us infinity solution. We can put value of x, value of y from 0 till the end. Till the end. But it is saying, okay, you solve justification that we have provided you, and graphically you have to plot. You have to plot. So let's begin. We have two equations. First is x plus y is equal to 3, and second is x minus y is equal to 1. Let's find solutions. Okay, at least two or three, so that we can plot all coordinates that we will have on the okay. X plus y is equal to 3. Clear? Now what to do now? What to do after writing this? So you will write only one variable. You can see in front of it. It is a linear equation in two variables. It is a linear equation in two variables. What is a linear? Linear, which means the degree should be 1. Degree should be, you can say exponent of any variable in equation should be 1. Only 1. Then that whole equation will be linear equation. Now two variables. So here you can see x is 1. What if here was what? X. Then we don't say that this linear equation is a two variables. No, this linear equation would be in one variables, because x we are taking same x. That's why. When we take a different letters, then we consider different. For example, this is one variable. This is second variable. That's why we are saying we have two variables in a linear equation. Okay, that's why we are saying. So, are you clear that this is a linear equation in two variables? Yes. Clear. Now only one variable we will shift one side, and all terms we will shift in another side. Only one variable we will shift one side, and all terms we will be shifting in another side. As you can see here, I am taking this side. Even you can take this variable in one side. 3 minus 5. In here you will be clear. Now it is saying when we will plot a value of y, any word, any number, then you will get something as a x. Now we can draw a box. Now we can draw box here. As of now, we are finding only two solutions of this linear equation. Only two solutions. You can find more solutions apart from two. Here, let's say this is x and this is y. Here, if we put in place of y, if you want to start from 0, then yes, you are right. There is nothing wrong. Okay, there is nothing wrong. can start from zero. It will be better, it will be easy, it will be efficient for you. Even I am starting from zero. Okay, pi, when y in place of y is put a zero, then x will come as a 3. You know, 3 minus 0, 1, then 2. So we have found two solutions of this linear equation. Now what about next? Same we will do for next. X minus 1, x minus y is equal to 1. X y plus y, x is equal to y, 1 plus y. We are drawing a box. Now here, if we will take y as a 0, then we will get x as a 1. If we will take 1, then we will get x as a 2. So finally we have found the solutions of two variables, of two linear equation. Now we need to draw a graph, okay, a graph in which we can plot this coordinates, okay. So I think 0, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Clear? Minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. 1, 2, 3, 4. This vertical line is considered as a y-axis, and this horizontal line is considered as x-axis, as you know. Here it is a graph. It is a graph of a coordinate geometry. Now x as a 3. Where is a 3? Where is a 3? On x-axis. So 3 is here. 3 is here. Clear? Okay. We got it. Next, y. So 3, 0 is a coordinate. So y as a 0. So y as a 0 is here. What is happening? So you can say this one point. Yes, this one point. Now x as a 2. This. What I'm saying? Oh, what I'm saying? Yes. One coordinate point is here. No, x as a 2. Where is x? This. And y as a 1. So it will come. So this is y as a 1. This is x as a 2. It is coming. Point is coming over here. Okay. This is clear now. This box. X as a 1. Where is the x as 1? This. And y as a 0. So third point is here. X as a 2. Okay. X as a 2. And y as a 1. So again, it is a here. It is a where? Here. Now you can see what will happen. This. Let's start from this. First this was, and second this. This is giving us a linear line, a straight line. So this straight line is of this. Now what about this? 1, 0. So 1, 0 this, and 2, and second is this. And this straight line is for this box, and this is of this box. Okay, that's how you will plot after finding solutions. you will understand if two lines are intersecting to each other, then what will we say? Those two lines. If these two lines are not intersecting to each other, both lines are parallel to each other, then what will we consider those lines? We will understand uh, just after a few minutes. As you know, these two lines are intersecting to each other, so we cannot say that these are two parallel lines. These are two parallel lines. We cannot say because of both are intersecting. Both are intersecting. Now next question. We have to apply substitution method. By using substitution method, we will solve this two linear equation, which is in two variables. Let's begin from 1. 2x plus y is equal to 7. Now here, one variable we will take one side and all terms we will shift in another side. 7 minus 2x. Now, what does the substitution method say? What does the substitution method say? It says that just you find the value of one variable and then put that value of that variable in another linear equation. That's how you have to do. Let's say this was 1 and this is the third. Why? 4x minus 3y plus 1. 4x minus 3y plus 1 is equal to 0. It is a what? Second equation. It is a second equation. So 4x minus 3 is equal to minus 1. So here 4x is equal to, so here we will use substitution method. It means we will substitute the value of y in this equation. So 4x minus 3, 7 minus 2x. Now can you tell me, by doing that, what will we get? We will get a value of x. We will get value of x. Now we have a linear equation in one variable, not in two variables. Here in this equation we have what, a linear equation in two variables, but in this equation we have a linear equation in one variable. From this equation we will get value of x. Value of x after putting after substituting value of y. So 4x and 21. This I think it should be plus. Okay. What else? 3 to the 6. X is equal to minus 1. Clear? 10x, okay, minus 1 plus 21. X is equal to 20 upon 10. 10 to the x came as 2. X came as 2. Now what will we do? We will substitute a value of x in third equation. You can write value of x in third equation. Clear? You can say 7 minus 2x. This is the third equation. We are substituting value of x in this equation. 7 minus 2 multiple how much? 2. So y 7 minus 4. So y came as a 3. So finally you can say x after using a substitution method. We got x as a 2 and y as a 3. That's all. That's how substitution method is applied. Have a look, then I will take next question. Next question. It's the next question. In this question, we have given linear equation and two variables. We have to use a substitution method. Question is saying, I am not saying. Question is saying use a substitution method, then find value of x and y. Okay, we will use. This is what is our work. Okay. So here, as you can see, each terms except minus 2, each terms are in fraction. So we will do what? Cross multiple? No, we will take LCM. You can say what will I do? Yeah. 3x upon 2 minus 5y upon 3 minus 2. I am starting from here, from this equation. As you know, this 6, 2 3s are 3 3s are 9, 3 2s are okay, 5 2s are okay. So you can directly write minus 12. Yes. So now we can take it as a Hold on. 3 3s are 9, 5 2s are 2 5s. No. Okay. So I am considering this as a one equation. Okay. As a one equation. What about this? Same for this. You can say 3 to the 6, okay? 2 3s are, so 3 3s are 9. 3 2s are 5 2s are 10 is equal to, so you can directly write, hold on brother, it is done here. Now this is the next, 3 to the 6, okay? 3 to the 6, 2x plus 3y is equal to 13 upon 6. 6 will get cancelled out. We have left 2x plus 3y. 2x plus 3y is equal to 13. Now this is a second equation. we have to use what substitution method. As you know, we will take only one variable in one side and all terms we will shift in another side. As you can see, 9x, okay, minus 12 plus 10y, okay, no problem. X, and here we can take a common. What? 6 to the no 5, 2, 2 we can take. 2 minus 6 plus 5y, 5y upon 9. Clear? Now this is you can see third equation. It seems like it is a difficult, yeah, it is a strange equation, but don't worry, just take one step forward. Okay, logically we will do now what? We will substitute this, value of x in this. Even you can put in this, in this. So x in third equation, no, x in second equation. 2, okay, minus 12 plus 10y, 2, okay, minus 12 plus 10y upon 9, this plus 3y is equal to 30. Okay, now we have a linear equation in one variable. From this equation we will get value of y, then we will put a value of y in third equation. That's it. We will get what? Value of y and x. Here minus 24 plus 20y upon 9 plus 3y upon 1 is equal to 30. Yeah, 9 ones are 9, okay, minus 24 plus 20y plus 9 3s are 27. Now you can directly write what? 9 3s are 27, 2, so 170. Here 20y, 27y, so 47y, 120 plus 24. We are getting what? We are getting what? 47y is equal to 100. So you can say 3, no, 1, 2, 3, 4 and 1. So 141 upon 47. I think it 47 will cut 141 by 3. Even you can multiply. 1, 2, 3, 4 is 12. 12 to 40. Yes. So finally y came as a 3. Now what will we do? We will substitute value of y in third equation. Y in third equation, isn't it? I can confidently say that answer of y is correct. Now here x is equal to minus 12 plus 10 multiple y is 3 upon 9. Here minus 12 plus 30 upon 9. Okay, no problem. Can you see this? Is the text visible or not? Yes, you can see. I am solving this forward here so that you can see. Here I can take a common. Okay. X. What 4 threes are, and I think 3. I can take 3 minus 4. 3 minus 4 plus 10 upon 9. 3 threes are 9. Okay. So finally I have what? 14. I have 14. No. 6 upon 3. 3 to the 6. X came as a 2 and y came as a 3. So finally you have a value of x as a 2 and value of y as a 3. After applying substitution method, you can see I can say that our answer is correct. Even you can check when you will put the value of x, value of y, which came, and value of this, just put in this, then you will get. As you can see, this 2 and this 3. 3 to the 6 will cut, and here 3 to the 6. So 3 to the 6. So 2 to the 4, and yes. So are you clear here? I want to show you proof. I wanted to show you a proof. Is our answer correct or not? X came as a, so you can say this is method. Here x came as a 2 and y came as a 3. 13 upon 6. 3 to the 6, 3 to the 6, 2 to the 4, 2 3 the 6, 3 3 the 9. 13 upon 6. 6 will cut. 13 is equal to 13. LHS is equal to RHS. That's why our answer is correct. That's why our answer is correct. Now next question. Next method. you can see there is a word which is elimination method. We were applying what? Substitution method. Now we are applying elimination method. We have two linear equation in two variables. We will apply elimination method. I know you are not familiar with the elimination method. I know. Let us say elimination method says that just to multiple a number a number in two sides so that you can get value of a variable same okay same in two equation in both equation. For example, this is one equation, this is a second equation, and you have to think that what will be that number when I will multiply with this and this I will get what? This one variable, this one. Like variables should be equal, not a different. When I will multiply with those numbers, then I should give what? Like terms with variables. You can see 10x, so 10x plus 3y is equal to 75. Yeah, this is first equation. Now next, first equation. Now this is first equation. 6x minus 5y is equal to 11. There are two equations. We have to think about those numbers. For example, if I am thinking that I will multiple this and this by 5 and this by 3. If I do like that, then I will get this and this equal. It will be 15 after multiplying this whole by 5, and after multiplying this whole by 3, then I will get this variable, this term as a 15, and this as a 15. That's why I took this two numbers. You can take another two numbers, but you should give what? One variable in both should be equally. Okay. By doing that, what can we get? You can observe, you can see. So first point, you have to be clear that this is known as elimination method. This process is known as elimination method. Okay, when we multiply in both equation by some numbers. Now 550 x plus 15y, and here 5 5s are okay 35 and 37. Okay, 37. 3 6 are 18x minus 15y. Now I did like that, then I got what? 50 50y. Both coefficient number and variable are same. Yes, operators could be different. We don't care about the operators, but coefficient and variable should be same, and then it will be known as that we applied what? Elimination method. Now what will we do? So here this will cut, minus and plus. So here we will add what? 8 4. Here we are getting what? 2 4 minus 32. Now 32, 4 2s are 8, 4 2s are 8, 4 3s are 12. I think 9. 9 2s are 18. 1. 9 3s are. We are here doing, we are adding. Yes, we are adding. We are adding. Remember, if operators are different, then you have to add. If operators are same, from this you can see. If this is coming plus, then you have to add. If here will come minus, then you will have to subtract. So here we will add 8, 8, 6. Now 68 adds up. 68 adds up. 68 adds up. So here 48 4 36 40. Yes, x 408 upon 68. This will cut. So x is equal to 4. Now we can put a value of this in any equation. Let's take this. 10 multiple 4 plus 3y is equal to 75. 40 plus 3y is equal to 75. 3y is equal to 75 minus 40. Yes, 3y is equal to 5. 5 3. I think yes, 35. So here 35 upon 3. What is happening? No, brother, this is a 6. This is 6. What happens with me? This is almost 6. 60 plus 3y is equal to 75. 3y is equal to 75 minus 60. That's why we are getting how much? 15 upon 3. 3 5s are 15. Y came as a 5 and x was as a 6. So these are answer. It is saying, sir, that x came as a 6, y came as a 5. Even you don't believe, then you can put a value of y, a value of x in any equation, then both sides will be equal after substituting value of y, value of x. Do you want to do same? Okay, don't worry. 6 multiple 6 minus 5 multiple 5 is equal to 11. You will realize that both sides will be equal to each other. 36 minus 25. Now 1, yes, 1. So you can see both sides are equal. That's why our answer is correct. Now next question. This was elimination method. Now I am going to take next question in which we will apply same elimination method. This was one question based on this was one question which was to use elimination method. if we are taking any one number multiple to multiple with one equation, here you are not you are not multiplying only with one side. No, you have to multiple with that number which you are taking, and you will have to multiple in both sides. Then question will be same. If you multiple, if you multiple by a number uh, with both sides, then nothing will be changes. Question will be same. Okay, that's why we take any number, any operator. Okay, now this is question. We have to apply same elimination method. We can see each terms are in decimal. We can remove by multiple. So I think if you take 10 number, if you will take a 10 number, then 10 number will remove all these decimals. X 1.5 is equal to 6.5 multiple 10. Okay, 0.3x plus 0.2 y is equal to 0.9 multiple 10. Clear? Now this whole equation will give us what? 4x plus 4x minus 15y 65. Yes. Even you don't believe, then 10 multiple 0 0 6 5 0 5 6. After one digit, yes, 65. Clear? Now same here, 3x plus 2y is equal to 9. Now we will apply elimination method. We are applying, but here two variables are not same with the coefficient. Two coefficients are not same with one variable. That's why we cannot say that we have applied elimination method. So here I am going to take what? This whole by 3, this whole by 4. Then let's see what happens. 4 is 12x minus 15y is equal to 3 5s are 15, 1, 3 6 are 18, 90. Clear? 4 3 is 12x plus 4 2 is 8y is equal to, I think, 36. It should be 36. Clear? Now here you can see plus plus. So here terms are same. So can you say here we will get minus? Of course, we are getting minus. So it means you have to subtract. Like that. Okay. Now here you are getting how much? 7y. Here you are getting how much? I think so. 9. Yes. 8. So 5. Yes. Okay. No problem. Now what else? Here we what happened? Hold on. It is okay. 45. So now we will get 7 and here 3. Now this is correct. This will be correct. 4, 21, 25. 20. Seven sevens. Again, minus plus. So 3 and 5. So here 5 3 multiple 3. I did wrong here. Okay, I was adding. No, I was subtracting, but minus minus it will tell us that just add and use multiple use subtract and 3 3 is a 9, 3 5 are 15. Yes. So here you can say y is equal to 159 upon minus 53. So minus 3. Y came as a minus 3. Y came as a minus 3. Y came as a minus 3. Now here we will substitute value of y in any equation. 4x minus 15y multiple minus 3 is equal to 65. 4x plus 45 is equal to 65. 4x is equal to 65 minus 45. X is equal to, so here 0 I think, 0 2 upon 5. So x came as a 5 and y came as a minus 3. So this is answer. Even you can check. I would like to show you 3 multiple 5 plus 2 multiple minus 3 15 minus 6 is equal to 9. So yeah, 9 is equal to 9. So yes, our answer is correct. Now next question. Just have a look. Just have a look. I'm going to erase it. This is the next question. Carefully look at this question. Here you can see 1 upon x plus y, 1 upon x minus y, 1 upon x plus y, 1 upon x minus y. Can you take, here we have to apply what elimination method is the same, but terms are changed. Okay, terms are changed. Here we can take x plus y as a 1 upon x plus y as a and 1 upon x minus y we can take this as a okay, as a clear. Now can we write 5m minus 2n is equal to minus 1? Yes, this is one equation. Now 50m plus 7n is equal to 10. This is a second equation. We will use elimination method. So in this by 7, in this by 2. Then we will get this equally. 35m minus 14n is equal to minus 7 is equal to minus 7. 30m plus 14n is equal to 20. Clear? Now here we are getting this. Okay, hold on. Here we have different operators. It means we will add. We have different operators. We will add. We will add. So here 5, 6. M is equal to how much? 27. So 27, 5. No. 35 sir. 35 sir. So here 5 and 2. 2. So here 5. So 6. I think here should be what? 5. Not 5, 13. So here, of course, here should be how much? 13. Now, n is equal to 13 upon 65. 1 upon 5, n came as a 1 upon 5. N came as a 1 upon 5. We will substitute this in an equation. 5 multiple 1 upon 5 minus 2n is equal to, so 5 1 minus 2n is equal to 1 minus 2n 1 minus 1 2n. Hold on, what is happening? This is minus 1, this is minus 1, so minus 2 upon minus 2 1. N came as a 1, n came as a 1. Now we will substitute this value with this 1 x plus y is equal to 1 upon 5. So here you can say this is 5, and next 1 upon x minus y is equal to how much? 1. So here you got x minus y is equal to 1. Now again we will do one thing. What? X plus y is equal to 5 x minus y is equal to 1. Here this is a 13. Now operators are same, it means we will subtract. So 2y and 4. 4 upon 2, 2 to the 4, y is equal to 2. Now we will substitute a value of y in this, in any x plus 2 is equal to 5. So x came as a 3. Clear? So y came as a 2, x came as a 3. This is final answer. X came as a 3, y will come Yes, answer is correct. Next question. In some cases, in some cases, you will do one thing. What? In some cases, here you are you are looking what numbers are big. In that case, you will what? You will do just subtract or add. Then you will get a coefficient number as a small, as a small. Okay. In that case, you do one thing. What? Just add both equation. Then in other hand, just add both equation. Subtract both equation. For example, by adding 37x plus 43y is equal to 123. 43x plus 37y is equal to 170. By adding, okay, 0 7 8 plus 7 8, okay, 0 3 4 2. Here we can take common. What? I think 80 we can take common. Yes, 80 we can take common. 80x plus 80y is equal to 240. So 80 we took as a common. X plus y is equal to 240. X plus y is equal to 240 upon 80. So 3. So now you can see we don't have a coefficient. Question is the same. We just added both equations. Okay. Now we will subtract both equation. 37x plus 43y is equal to 122. 43x plus 37y is equal to 170. Minus. Here minus how much? I think 4. 43, 37, 6, only 6, minus 6x. Now here plus 6y. Here we are getting plus how much? I think 6. Yes, 6. Here we can take a common 6 as a common. So minus 6 x minus y is equal to 6. X minus y is equal to 6 upon minus 6. It is giving us how much? X minus y. X minus y is equal to minus 1. Now we have what? Simple. We have simple equation. you can consider it as a second equation and this as a first equation. Now, by using elimination method, x minus y is equal to 3x minus y is equal to minus 1. Here 2y okay, plus 4 plus 4 y is equal to 4 upon 2 to the 4 I can add a 2. We will substitute the value of this in this we can substitute. So x minus 2 is equal to minus 1. Minus 1 plus 2. X came as a 1. So finally, you got a y as a 2, x as a 1. So you will do like that when coefficient numbers are big, then you will do like that. Okay, just add both equation and then subtract both equation, then you will get simple equation. So when will you do like that? When you have a big coefficient number, then you can do like that.